Hey there, hope you're having a wonderful day. In this video, we're going to be coding the game Breakout, which is similar to Pong and also developed by Atari. And this game is similar in that you have a paddle, but the difference is it's a single player game. So you need to use the paddle to hit the ball so that it would break all the blocks or bricks. For that reason, the game is also known as Block Breaker or Brick Breaker. So just to show you what you'll have by the end of this tutorial, quickly we have a game over screen, but if I press the space bar, the game resets and I can slide the paddle around to destroy some blocks. And a nice thing about this tutorial is that we will create a new level every time each level is cleared. Of course, I'm not going to show you that now because there's just too many blocks. It'll take a long time. So I'll show you at the very end how I'm going to test that. So make sure you stick around. Also, very quickly, just before we begin coding, I just want to mention that I am working on a web dev tutorial series where I teach you how to create games using HTML, CSS, and JavaScript. So if you go to kennyupcoding.com or if you visit the videos on my channel, you'll find that I have tutorials on Pong and currently Breakout, Flappy Bird, Space Invaders, Wordle, Sudoku, 2048, Candy Crush, and many more. And my next tutorial will be Doodle Jump. So if you want to stay up to date, make sure you subscribe to the channel. Alright, start by creating 3 files, index.html, breakout.css, and breakout.js. So for our index.html, we're going to have doctype HTML. Within the HTML tag, we're going to have a head tag, meta charset is equal to UTF-8. Meta name is equal to viewport. Content is equal to width equals device width. Initial scale is 1.0. Let's also give a title to our web page, Breakout. Let's link our CSS file. Rel equals style sheet. href is equal to breakout.css. Oops. And for our JavaScript, script source is equal to breakout.js. And that's all we need for our head tag. Now let's add a body tag. And within our body tag, all we need is a canvas tag. So this is where we're going to paint our game. So I'm going to assign it an ID board so I can use JavaScript to access this canvas tag. Alright, let's move on to the CSS. I'm going to add some CSS for the body, and I'm just going to do text align center. So this is going to center our canvas, and I'm going to access the canvas tag, which is the board. So using the ID board, I'm going to set a background color for the canvas and make it black. Alright, so if I open up the index.html file, you can see we have a canvas and the background is black. Alright, so within our JavaScript, I want to modify the height and width of the board. So I'm going to add some variables here. So let board width, I'm going to set that to 500. And board height, I'm also going to set that to 500. And create a variable context. Okay. So when our page loads, I'm going to do window.onload and call it function. And I'm going to get the board. So this is document.getElement by ID board. So this is the canvas tag. And basically we are assigning that canvas tag to this variable board. So now we can use this variable to draw on the canvas. Okay. And I'm going to set board.height to board height and board.width to board width. And I'm going to get the context, board.getContext 2D. So this is used for drawing on the board. Alright, now if I refresh the page, you can see we have our board, which is 500 pixels by 500 pixels. Now within the CSS file, I want to add 3 more lines, and that is the border top, I'm going to add a border to the top, 5 pixels solid, and make it sky blue. And let's add one for the left side and one for the right side. Alright, so now you can see we have our border left, border top, and border right. So I added these so that we can see visually where the walls are going to be, so that the ball will bounce off these walls. So just for a quick recap, I just want to quickly explain how the canvas works. So we have our canvas, which is 500 by 500. This top left corner is 0, 0. So this is the x coordinate and this is the y coordinate, 0, 0. Down here is 0, 500. All the way to the right is 500, 500. And then back up, we have 500, 0, which is the top right corner. So when we draw on the canvas, we need to specify the x, y coordinates. And remember that they start from the top left corner. Alright, let's draw the player, which is the paddle. So to draw the player, I'm going to add some variables. So let's specify a width, and I'm going to set it to 80. And a player height, I'm going to set that to 10. And then I'm going to create a player object. So this is going to be a JSON object where I'm going to add some properties, x, and this will be board width divided by 2 minus player width divided by 2. Y is going to be board height minus player height minus 5. Width is going to be player width. And height is going to be player height. Alright, so now that we have x, y, width, and height, so I'm going to explain what these numbers mean, but for now let's add 2 more lines to draw the player. So let's draw the initial player. Context.fillStyle is equal to sky blue. And context.fillRect, player.x, player.y, player.width, and player.height. Alright, so if I refresh the page, you can see we have the player, which is the paddle here, and it is perfectly centered and just 5 pixels above the bottom of the canvas. Actually, I forgot. I was going to change the color to light green, so let me do that here. So instead of sky blue, let's use light green, or you can use whatever color you want. Alright, so if I refresh the page, we change the color to light green. Alright, so what do the numbers mean? First, we need to specify an x and y coordinate because we want to figure out how to get to this point. So for the x coordinate, it goes horizontally. So ideally, we want it at the halfway point. But if I do board.width divided by 2, it will go up to here. And this is where we would start drawing the rectangle. So to make this board stay in the center, we need to move it back 1/2 over. For that reason, we do board.width divided by 2 minus player.width divided by 2. So now that should give us this point. But how do we get the y coordinate? So we take the board, the entire height, so it would start here if we drew the paddle. So this would be board.height. So what we need to do is move it up the player height so that it would start right here. And then I added an extra -5 so that it would not stick directly onto the bottom of the canvas. Alright, so now that you know how drawing on a canvas works, let's talk about the game loop. So whenever I move the player to the left or to the right, I need to update the canvas. So what I need to do is update the canvas over and over again so that it will redraw the new positions of the paddle. And this would also apply for the ball and these bricks. So I need to constantly paint on the canvas. Therefore, I need a loop. So for the game loop, I'm going to add request animation frame, and it's going to call a function called update. Let's define that function here. And I'm also going to call request animation frame update inside this function. And let's copy this and place it in here. Okay. All right, so if I refresh the page, we are now in a game loop. The canvas is drawing over and over again, but you don't see a difference because nothing changes. So we need to add some key events so that I can move the paddle left and right. So to move the player, we need to specify a velocity because the velocity is the change in position over time. In breakout, the paddle only moves left and right, so we only need to worry about the X position. So let's create a variable, player velocity X, and I'm going to set this to 10. This means that each frame, the player will move to the right or to the left 10 pixels, and this will depend on which key we click. So within the player object, I'm also going to add velocity X and set it to player velocity X. And over here, let's add the key event listeners. So I'm going to do document.add event listener. It's going to listen for a key down. Basically, whenever you click a key, the key goes down. You can also hold the key. I'm going to call a function called movePlayer. So within here, let's define that function. And we're going to pass in a variable e, which will be for the key event. So if e.code is equal to arrow left, we want to move left. So I'm going to do player.x minus equal player.velocityx. Else, if e.code is equal to arrow right, player.x plus equal player.velocityx. So if this is 0 and this is 500, that means if I move left, I need to subtract. And if I want to move right, I need to add. And likewise, if I want to move up, I need to subtract. And if I want to move down, I need to add. Okay? Alright, now if I refresh the page and I press the left arrow key, you can see we're moving to the left. And if I press right arrow key, we are moving to the right. Now this might look a bit strange, and that is because we are overlapping our drawings. So we need to clear the canvas every frame before we draw something new onto it. Otherwise, the frames will stack. So within our update function, before we draw the player positioning, I'm going to do context.clearRect starting from 0, 0, board.width, and board.height. Alright, so if I refresh the page now and I click arrow left, you can see we clear the previous frame and we redraw the new one with a new position of the paddle. And I can do arrow right as well. Now we need to take care of one issue, and that is we can actually fall off the screen. Alright, to fix this, I'm going to comment this out and create a variable called nextPlayerX and set it to player.x minus player.velocityx. So instead of directly updating player.x by subtracting the velocity, I'm going to calculate this value and store it in a variable, and then I'm going to check to see if that value is out of bounds. So up here, let's create a function out of bounds, and I'm going to pass in an x position. And this is going to return a boolean telling us whether the player has moved out of bounds or not. So I'm going to return x position is less than 0. This means that we've gone past the left screen, or x position plus player width is greater than board width. This means we passed the right screen. So how does this math work? Alright, so if I move the paddle to the left, and we have this top left corner, which is the x and y value, if this x value is less than 0, 0 being this border, then we know we've gone off screen. Now for the right side, we need to make sure that the top right x value of the rectangle, we need to make sure that this exceeds 500, which is the right border over here. So this is x equals 500. So to check that, how do we get here? Well, we just take the x coordinate here and we add the width. So this would be x plus the width, y. So we need to make sure that the player x plus width exceeds the board width. All right, so over here, I'm going to check if not out of bounds, next player x, we are going to update player.x to next player x. And we need to do something similar for our right. So next player x is going to be player.x plus player.velocity x. If not out of bounds, next player x, player.x is going to be next player x. Alright, now if I refresh the page and I press the arrow key to go left, you can see I cannot go further left because we will go out of bounds. So that's where a check comes in. And if I try to go right, we do not go out of bounds. Alright, so now that we have a functional paddle, let's create the ball. So to create the ball, I'm going to need a few variables. So I'm going to create a ball width of 10, ball height of 10. We need a velocity, x and y, because the ball can go up and down. So ball velocity x, I'm going to set this to 3, and ball velocity y, I'm going to set this to 2. Let's also create an object for the ball. So we need x, which is going to be board width divided by 2. The y position is going to be board height divided by 2. The width is going to be ball width. The height is going to be ball height. Velocity x is going to be ball velocity x. And velocity y is going to be ball velocity y. And within our game loop, let's draw the ball. So currently the pen is light green. I'm going to change it to white. So context.fill style. Let's set it to white. And before we draw the ball, I want to update the x and y values with the velocity. And then I'm going to do context.fillRect, ball.x, ball.x, ball.y, ball.width, and ball.height. So to draw the ball, we need an x and y position. So the x position is board width divided by 2. And the y position is board height divided by 2. So it gets us this top left corner, and we specified the width and height as 10, 10. Okay? Now for the velocity, we are changing the x position by 3 over time and 2 vertically. So we expect the ball to go in this direction. Alright, so if I refresh the page, you can see the ball is going towards the right and downwards with a velocity of 3 to the right and 2 downwards. So what we need to do now is make the ball bounce off these walls. So over here, I'm going to make a series of if condition statements. Bounce ball off walls. So we're going to check if ball.y is less than or equal to 0. This is the top of the canvas. So if ball touches top of canvas, I'm going to set ball.velocity y and reverse it. So I'm multiplying it by -1. Else, if ball.x is less than or equal to 0, which is the left border, or ball.x plus ball.width, which is the top left corner plus the width gives us the top right corner. If this touches board width, which is the right border, so if ball touches left or right of canvas, we're going to flip velocity x. And we actually have one more condition, and that is the bottom of the canvas. So else if ball.y plus ball.height, so ball.y again is going to start from the top left corner, and we want to get the bottom left corner, so that's going to be ball.height plus ball.y. If this touches board height, we're going to do game over. So this I'm going to handle towards the end. So basically, if the ball is going this way and it touches the right corner, we want to flip it backwards, right? So it's going to go this way. And the same applies. If it goes this way, we're going to reverse the y velocity. So it's going to go down. Before it was going up, now it's going to go down. All right, so if I refresh the page, we expect the ball to go downwards towards the right. And if it touches the right border, it should still go downwards, but now towards the left. So it should reflect off that wall. And there you have it. So now that the ball can bounce off the walls, we need to make the ball bounce off the paddle. So to do that, we need to detect a collision between the paddle and the ball. So down here, I'm going to add a function to detect collision between two rectangles, A and B. And we're going to use a formula. So a.x is less than b.x plus b.width. And so this is A's top left corner doesn't reach B's top right corner. A.x plus a.width is greater than b.x. And so this is A's top right corner passes B's top left corner. A.y is less than b.y plus b.height. So A's top left corner doesn't reach B's bottom left corner. And A.y plus A.height is greater than B.y. So A's bottom left corner passes B's top left corner. So this is to check the intersection between two rectangles. Now what we need to do is add a few more functions to detect which side the collision was detected on. So for top collision, I'm going to pass in the ball and a block. So this block will be the paddle, but it's also going to be the same function we use to detect collision between the ball and the blocks on top. So in this case, A is the ball, so A is above B, meaning that the ball is above the block. I'm going to return detect collision of ball and block, and ball.y plus ball.height is greater than or equal to block.y. Alright, so to detect the top collision, we need to make sure that the bottom of the ball exceeds the top of the block. So the reason why I say exceeds is because going down is positive. So we need to check for the coordinates. So the y coordinate starts at the top left. So to get to this bottom coordinate, we need to add the height of the ball. So for the ball, we need to make sure that y plus h is greater than or equal to the top of the paddle. So for the block, we need to make sure that it's greater than block.y. And for the bottom collision, we're going to do something similar. So A is below B, and we're going to return the type collision of ball and block, and block.y plus block.height is greater than or equal to ball.y. So to check for the bottom collision, we need to make sure that the bottom of the paddle exceeds the top of the ball. So to get to the bottom, we need y, which starts here, add the height of the block, and it has to exceed the top of the ball, which is y. Let's also do left collision. So we're going to return the type collision of ball and block, and ball.x plus ball.width is greater than or equal to block.x. Okay, so if we have a left collision, we need to make sure that the right side of the ball exceeds the left side of the paddle. So to get the right side of the ball, we just need the x coordinate plus the width. And we need to make sure that this exceeds the x coordinate of the paddle, which is the left side. Okay, and then finally, the right collision. So we're going to return the type collision between the ball and block, and block.x plus block.width greater than or equal to ball.x. Okay, so we need to make sure that the right side of the block exceeds the left side of the ball. So here is the x coordinate. To get to the right side, we need to add the width of the block to get to this point. So x plus width needs to exceed the left side of the ball, which is just x. Okay, so I'm going to scroll back up to the update function, and then down here I'm going to check. So this is going to be for bouncing the ball off player paddle. So if top collision, ball player, or bottom collision, ball player. So if there is a collision on the top or bottom of the paddle, we need to flip the velocity y of the ball. So ball.velocity y, we're multiplying this by -1. So we're going to flip y direction up or down. Else, if left collision of ball and player, or right collision, I'm going to flip the velocity x. Alright, so if I refresh the page, you can see the ball bounces off the walls, and we can bounce it off the paddle as well. So let me try to catch this one over here. Alright, so now that we have the ball bouncing off the walls and the paddle, let's create the blocks. So let's create some variables for our blocks. And since we're going to have many block objects, let's use an array to store them all. And for each block, I'm going to give it a width of 50 and a height of 10. And we're going to have a variable block columns. So we're going to have 8 columns of blocks. And for the rows, let's just make it 3 for now. So we're going to add more as game goes on. So every time we clear a level, we're going to add another row of blocks. And if we keep adding rows of blocks, eventually we're going to touch the paddle the player panel. So we don't want that. So let's limit how many rows we can have. So I'm going to create another variable called max rows, and I'm going to set it to 10. So this is to limit how many rows of blocks we can have. And then I'm going to add another variable called block count and set it to 0. So this variable block count is going to keep track of how many blocks are there. And every time we destroy a block, we're going to decrease the block count by 1. If block count is equal to 0, we're going to create a new level with more rows. So this variable is going to keep track of how many blocks still remaining in this level. And of course, to draw the blocks, we need an X and Y position. So this is going to be the starting block corners. So block X is going to be 15, 15 to the right, and 45 down. So when the page loads, I'm going to create the first set of blocks. And I'm going to call a function called createBlocks. And then I'm going to define that function down here. So before I create the blocks, I need to clear the block array. And we're going to do for let C equals 0, C less than block columns, C++. For let R equals 0, R less than block rows, R++. Let block equal to an object. Oops, this should be an equal symbol. Let block equal to an object. X is going to be block X plus C times block width. And Y is going to be block Y plus R times block height. Width is going to be block width. Height is going to be block height. And we're going to add another property, break, and this is going to be false. And then after that, let's push that into an array. So block array dot push block. And at the very bottom, we're going to set block count equal to block array dot length. All right, so now that we have our blocks in our array, we need to draw them. So let's go back to our update function. And down here, I'm going to draw the blocks. So first, I'm going to set context.fillStyle to sky blue. So this will change the pen color to sky blue. And I'm going to iterate through the block array. For let I equals 0, I less than block array dot length, I++. Let block equal to block array of I. And if not block dot break, so we only want to draw the blocks that have not been broken. Context.fillRect, block.x, block.y, block.width, block.height. Alright, so now if I refresh the page, you can see we have our blocks here, but unfortunately, the blocks are all stuck together. So we need to add some spacing between the blocks. So down here, I'm going to add C times 10. So C times 10, we're going to space 10 pixels apart columns. And over here, we're going to do plus R times 10. So space 10 pixels apart rows. Alright, now if I refresh the page, you can see we have our blocks and there is 10 pixels spacing between each block. So now we need to check for collision between the ball and the blocks so that we can break each one. So within the same for loop, I'm going to check. If the block has not been broken, before we draw the rectangle, I need to check to see if there's a collision. So if top collision, ball and block, or bottom collision, ball and block. So this is either the top or bottom. We're going to set block.break to true and set ball.velocity y, multiply it by -1. So it's going to flip the y direction of the ball. And I'm going to decrement block count by 1. And let's do something similar for the left and right collision. So over here, we're going to set ball.velocity x times equal -1. So we're going to flip x direction, left or right, and decrement block count by 1. All right, now if I refresh the page, you can see I bounced the ball off the paddle. The ball touches the bottom of one of the blocks, and then it reverses direction. So now we have a functional game of breakout. But of course, to have a fun game, we need to keep track of the score. So let's add that. So down here, I'm going to add a variable score and set it to 0. And then back here, every time we break a block, let's increment the score by 100. So score plus equal 100. And down here as well, score plus equal 100. And then down here, let's draw the score onto the canvas. So context.font, we're going to set it to 20 pixels. Sans serif, context.fill text, score, and it's going to be 10 to the right and 25 pixels down. Now if I refresh the page, you can see we have our score 0 on the top left. And if I break one of the blocks, we get a score of 100 each time. And let's add a check for game over. All right, so right below our score variable, I'm going to create a game over variable and just set it to false. And within our update function, if game over is true, so if game over, I don't want to update the canvas anymore. So I'm just going to return. And for the game over condition is when the ball touches the bottom of the canvas. So this part, so if ball.y plus ball.height, which is the bottom of the ball, if that exceeds board height, that means we've touched the bottom of the canvas, game over. So I'm going to add a message. So context.font, I'm going to set this to 20 pixels, sans serif, and then context.fill text. Let's add a message. So game over, press space to restart. And let's place it 80 pixels to the right and 400 pixels down. And over here, I'm going to set game over to true. All right, now if I refresh the page, let's let the ball go to the bottom. You can see as soon as the bottom of the ball crosses the bottom of the canvas, we get this message. And as you can see, even if I press the arrow keys, we are no longer painting on the canvas. So over here, I have a message that says press space to restart. So let's respect that and give the player an option to restart the game. So to restart the game, we need to add a key event for the move player. So we're going to check if game over, if e.code is equal to space, I'm going to reset the game. So I'm going to call a function called reset game. So let's define that all the way at the bottom. So if I reset the game, game over is going to be false now. So how do I reset the game? Well, I just need to place the player back to its starting position and the ball back to its starting position. So let's go ahead. And up here, I'm going to copy and paste this. Set that over here. Let's backspace this. So I'm going to reassign player to this starting object. And let's do the same thing for the ball. And then over here, I'm going to reset block array, make it empty, set the score to 0, and then I'm going to call create blocks. Okay, so basically we are restarting the game by placing everything back into its starting position. All right, now if I refresh the page, let's get a score. Okay, now let's wait for the ball to drop to the bottom. You can see if I press space, we should expect the paddle to be at the center. The ball should be over here somewhere. All the blocks should be brand new, not destroyed, and our score should be 0. So if I press space, you can see we've reset the game. Okay. And let's try to get one more block destroyed. Okay, let's get this ball to the bottom. And if I press space, we reset the game. All right, so now we have covered the logic for the game and we are able to go back and restart the game. How about going forwards? So if we clear all the blocks, we want to create a new level for the player. So let's go and do that. So within our game loop, our update function, I'm going to scroll all the way down. Over here, I'm going to check for next level. Oops. So if block count is equal to 0, I'm going to set block rows to math.min of block rows plus 1 or block max rows. So what I'm doing here is I'm going to update block rows and add another row up to the max rows. And then I'm simply going to call create blocks. And before we begin the new level, let's be generous and give some bonus points. So 100 times block rows times block columns. So as a reward for clearing all the blocks, we're going to add 100 points for the number of blocks cleared for that previous level. So this is just some bonus points. And because block rows will change after every level, if the ball falls below the canvas and we get a game over, we need to reset block rows as well. So let's go down here. And I'm going to reset block rows to 3. Okay, so let's go back up. All right, so this is our code for the next level. Basically, if block count is 0, if we cleared all the blocks, we give bonus score, add another row, and create blocks again. But how do we know whether this works or not? You would actually have to see me play through the game to test this code. So why don't we cheat a little bit? So I'm going to go all the way up here, and I'm going to change this from 3 to 15. And 2 to 10. So we're going to do 15 for testing. 3 is normal. Oops. And 10 for testing. 2 normal. And then I'm also going to change the player width. So I'm going to make this 500. So 500 will be for testing and 80 for normal. So if the player width is 500, we've basically covered the entire bottom border. All right, now that we've changed the variables, let's go back and check our game and see if we can advance to the next level. So sit back and enjoy. All right, so we are destroying the blocks. Okay, we are almost there. Come on. Okay. All right, one more. Okay, There you go, the next level. Alright, so now we have a fully functional game of Breakout, or Block Breaker, however you like to call it. So if you found this video helpful, please make sure to give this video a like, make sure you subscribe. If you have any questions, please let me know down below in the comment section. And you can also continue working on this game if you want to. You can make it so that every time you clear a level or you destroy a block, maybe there's a chance for the ball to go faster or for the paddle to go faster. So you would increase the velocity for either the paddle or the ball. Maybe you can also make the player width, the paddle, longer so that you can cover more area. So this is up to you, but that's all I have for this video, and I'll see you in the next one. Bye bye.